Okay, welcome back. We're going to talk about the adrenal glands now. So, the adrenal gland, when we look at the word adrenal, we have AD, which means you're adding something to the renal to the kidney. So, we have two adrenals. They're sometimes referred to as the suprarenal gland. When we look at the suprarenal gland, because it's above the kidneys, we can see that we have an outer portion called the capsule. The capsule is superficial to the main part, the outer portion called the adrenal cortex, and then the inner part is the adrenal medulla. And remember, the cortex is going to be pushing out glucocorticoids and mineral corticoids. The mineral corticoids is aldosterone, whereas the glucocorticoids are all of the C's, right? Cortisol, cortisone, corticosterone. They're going to be involved in raising glucose levels. The mineral corticoid is aldosterone, and its job is to hold on to sodium and then water. And then the adrenal medulla, the inside, that's where we have epinephrine and norepinephrine, or adrenaline and noradrenaline. So it's important to know the histology and the microscopic portions of the uh, cortex, the adrenal cortex. We're going to have three main regions, three zones. The zona glomerulosa, which is the most outside portion. The zona fasciculata, which is the largest area, which is more of the middle region. And then we have the zona reticularis, which is the innermost portion of the cortex. Now, that innermost portion is going to secrete androgens, whereas the fasciculata secretes the glucocorticoids, cortisol, cortisone, corticosterone, but mostly cortisol. The outer portion, the glomerulosa, is going to secrete mineral corticoids. Again, it's a little bit different than the glucocorticoids, right? The glucocorticoids are cortisol, cortisone, corticosterone. The mineral corticoid, when you think of mineral, we're thinking sodium, and that's the job of aldosterone. So the mineral corticoid is going to regulate mineral homeostasis. We're thinking sodium, which is aldosterone. The glucocorticoids affect glucose homeostasis. We're thinking cortisol, cortisone, corticosterone, and then the innermost portion is going to secrete androgens, which is going to have more of a masculinizing effect. Now, aldosterone is a major mineral corticoid that's secreted by the adrenal gland, and it's going to regulate sodium and potassium homeostasis. Remember, if this is the cell, if we have sodium coming in, then potassium goes out. So potassium is like the anti-sodium. Many people have high blood pressure, not because they're not eliminating sodium, right? People have been talking about lowering sodium for like 30 years, 40 years, and there's still people with high blood pressure. It's not a matter of decreasing sodium, I don't think. I think it's a matter of people's potassium levels are too low in relationship to sodium. So it's more of like, what is the relationship of the ratios between sodium and potassium? And maybe the sodium levels are normal, but maybe the potassium levels are too low. You're still going to have the effect of high sodium, which is high blood pressure. So there is a really important pathway called the RAAS system, the renin angiotensin aldosterone system. Sometimes they call it the RAAS, R-A-A-S, the renin angiotensin aldosterone system. Now, when you look at the word angiotensin, what do we see here? We see angio, which is like angiology, an angiograph, angiogram. Angio relates to blood vessels. And tensin, that word looks like tension. When we see renin, REN is like renal. That has something to do with the kidney. And aldosterone, we know. So let's take a look at this RAAS, the renin aldosterone angiotensin system. Your body wants to maintain good, equal blood pressure. We always want blood, not just going to the heart, but it's got to go to the kidneys. The kidneys are like a pump that's always constantly pumping fluid through it. Now, let's say we have a situation where we have low blood pressure, and you can have decreased blood pressure. You can have decreased blood pressure due to dehydration, a sodium deficiency, or really hemorrhage. You're losing blood, you don't have enough sodium, or you're dehydrated. That's going to decrease in the blood volume, and it's going to decrease blood pressure. Okay, so what is the body going to do as a result of decreased blood pressure? Because the kidneys don't want that. The kidneys, when you do the nephron, when you study the kidney and you look at the functional unit of the kidney, it's called the nephron. There is a portion of it that's called the JG cells, the juxtaglomerular cells, and these are secreting cells. They have the ability to secrete and release renin. Now, what is renin going to do? Well, I'll tell you right now. Renin is going to have an impact on something that the liver makes. Well, what is it that the liver makes? The liver makes something called angiotensinogen. Now, you've heard me say this before, that anything that ends in ogen means it's inactive. So angio is blood vessel, tensin from tension. So this hormone here, angiotensinogen, or this enzyme, or this chemical, this angiotensinogen has the ability of doing something, but it's inactive. So what renin does is renin bumps into it, and it knocks off the ogen and converts angiotensinogen into something called angiotensin 1. Now, if there's an angiotensin 1, it's probably safe to assume there's going to be an angiotensin 2. But how do we go from angiotensin 1 into angiotensin 2? Angiotensin 1 goes in the blood circulation, goes into the lungs. The lungs have an enzyme called ACE. And ACE stands for angiotensin converting enzyme. Well, what is angiotensin converting enzyme going to do? Well, it's going to convert angiotensin 1 into angiotensin 2. And what's angiotensin 2 going to do? It's going to constrict your blood vessels. It's involved in aldosterone production. It's involved in adrenocorticotropic hormone production. It's involved in ADH production. It's involved in increasing your salt cravings and making you thirsty. So let's look at these again. It's going to make your blood vessels constrict. Well, if you have a constricted blood vessel, your blood pressure is going to go up. It's involved in aldosterone production. This is all the things that angiotensin can do, all of these. What is aldosterone going to do? Well, aldosterone is involved in retaining sodium. And if you retain sodium or salt, you're going to retain water as well. Now, your body's going to push out adrenocorticotropic hormone. What is adrenotropic hormone going to do? Well, that's involved with the cortex, glucocorticoids, cortisol, cortisone, corticosterone. Cortisol is going to increase your heart rate. ADH, antidiuretic hormone. Well, it's going to allow you to hold on to water. Now, your salt cravings go up. So you eat potato chips, you eat pretzels, you add salt to food, and then when you eat salty things, you get thirsty. So you eat salty things, and then your body has the ability of using aldosterone to hold on to that salt. Then you become thirsty, and your body then releases antidiuretic hormone to hold on to the water that you just drank. So it's like the reinforcements. You're consuming salt, consuming water. You got aldosterone and ADH that's going to enforce that. So you hold on to salt, hold on to water. What's going to happen is your blood pressure is going to increase. And that's what this is showing down here. So it says angiotensin 2 which is going to constrict your arteries. When you constrict your arteries, your blood pressure is restored. We see aldosterone. Aldosterone is going to increase our sodium absorption, and it's going to allow secretion of potassium because remember, they move in opposite ways. When that happens, you increase blood volume, and again, the end result is blood pressure goes up. That's what we want. That's called the RAAS system. When we come back, we'll talk about stress and how stress can kill.